Amplify Science Plate Motion Engineering Internship, Chapter 1, Day 4, Learning about Tsunami Warning Systems. Step 1 of the lesson is warm-up, which takes you out to the Futura workspace. Taking a quick glance at Day 4, there are 3 items in your inbox. When you take a look at Day 4, Tsunami Warning Systems, what you're accomplishing today. With the after-hours work, they have a section called Explaining Tsunamis at Home. That is optional. It's something we encourage you to do, of course, going home and having conversations, but because it's not possible at every house, it's not something we're going to hold you accountable for in terms of progress and grade. When we step over to part 2, you're going into your dossier again, and this time it's a chapter 4 article. It is called Tsunami Warning System. So I'm going to hop over as quickly as I can. We've looked at chapter 1, chapter 2, chapter 3 for landforms and boundary types. Now here in chapter 4, Tsunami Warning Systems. This takes us through each of the sensor types, where they would be located, gives us more information about the real-world application and how they relay data and costs and breakage, things that can really help us in our progress. And here we have also a question as to what degree of helpfulness they are. So report back that. Then we hop over to Step T, and Step T includes a video. If you want to watch it outside of class, hop over to your lesson brief, and the video is presented there. But it's 4 minutes of an overview of each of the features in the Tsunami Alert System. Even though we've been in the alert system already, this really helps make sure we aren't missing any key details. And then the after hours work swings you back to making sure you've done everything from the daily message. But we'll probably get time to hop over to Day 5 and actually begin testing those systems. But before we do, we need to make sure we all understand that a sensor is a device that detects information in its environment and responds. As you analyze the sensors, things that they do well, things that they do poorly, everything comes at a cost. There's no perfect solution. So with the 3 sensor types, earthquake, shallow, deep, we want to check off what are they best at detecting and where should we place them in order to make them most effective. You learn that by the article in your dossier and also by practicing placing them on your alert system. Okay, so we want to consider plate boundary types, earthquake and tsunami activity, sensor characteristics, and project criteria as to build the best warning system. As we look at sensor performance, they remind us if you click on the sensor, either in the menu on the left or in the map, you get information. You see here example A, this sensor is detecting nothing. And on example B, you've got 5 detections, but 1 false alarm and 2 breaks. Example C and D, we now see earthquakes causing tsunami waves, and we can detect which sensors have sent data. The flag above the sensor tells us that. We can also see if we get a false alarm in example D, and then we can take action to try to solve that. In example E, we can see that a sensor has broken, the other one sent data. We can see the size of the earthquake. We can see that it's a whole ocean tsunami. And in this case, Sri Lanka gets no warning time. Even though the average warning time might be 27 minutes that you see in the left, not all necessary warnings were received, and that's not good. We want to protect from all occurrences that we can. So where must each sensor be placed in order to detect important information? How close to an earthquake can the sensor be before it breaks? And what combinations result in false alarms for Sri Lanka? Keep those things in mind. This is not an easy task. It's going to take a lot of trials or iterations, which you'll be moving to in Day 5. I do provide the Day 5 handout. If you get to that point and you want to start recording where each of those sensors are as you refine and get better and better and better.